Fractional exponents are a concept that's a little bit tough to wrap your brain around, but let's begin by examining some patterns. If I say to you x to the fourth squared, we know from our algebra that, we know that anything squared means we're multiplying it by itself. And we know from our exponent rules that when I'm multiplying, I add the exponents. I could also look back to taking a power of a monomial in this one, and know that I'm multiplying them. But any way I look at it, x to the fourth squared is x to the eighth. Therefore, we can prove, that's the proof, that the square root of x to the eighth is x to the fourth. Following that pattern down, if I say x to the third squared, that means x to the third times x to the third, which means that equals x to the sixth. Therefore, square root of x to the sixth is x to the third. You've probably already caught on to this now, but we're going to follow it down to the end. X squared squared means x to the second times x to the second, which is x to the fourth, proving that the square root of x to the fourth is x to the second. X to the first squared is x to the first times x to the first, which equals x to the second, meaning that the square root of x to the second is x to the first. In each of these situations, you've, I'm sure, seen the pattern that x, if I'm taking the square root of x to the eighth, it equals x to the fourth. X to the sixth equals x to the third. Square root of x to the fourth is x to the second. Always, the exponents are half. The exponents of the square root are half of what they were that you were taking the root of. So by following that pattern, you can see that the square root of x to the first must be x to the half of 1. And half of 1, as we know, is 1/2. This also makes sense if I think about the fact that x to the 1/2 times x to the 1/2, I add my exponents, that gives me x to the first. And also, if I think of x to the 1/2 squared, I'm multiplying my exponents. Any way I do it, it always works. So, if I took a similar pattern here, and I said the square root of 16 to the first, if I wanted to write that with a fractional exponent, I could see that that is 16 to the 1/2 power, which of course we know the square root of 16 is also 4. This makes sense because 16 to the 1/2 times 16 to the 1/2, I'm not multiplying these are the bases, gives me 16 to the first power. And we also know that 4 times 4 is 16. 16 to the 1/2 squared is equal to 16. I think we've firmly established that the other way of saying the square root of any number, say 25, if I want to write that with a fractional exponent, it's 25 to the 1/2 power. And if I want to write it otherwise, I could say that that's 5. We have never really looked at this before, but we know that, we haven't looked at this symbol before. We know that 2 to the third power means 2 times 2 times 2, which is 8. What we haven't seen before is a radical symbol with any other number here. When there's no number, we assume that we are taking the square root of something. But if there's a different number, we say we are taking the cube root or the fourth root or whatever. The cube root of 8 is how you would read this. 8. And since 8 is 2 to the third, the cube root of 2 to the third is 2. In other words, this means the cube root of 8 here what it's saying is what times itself, what to the third power is equal to 8, and that makes it 2. Again, we're going to follow this basic pattern down. If I say x to the third to the third power, I know that that means x to the third times x to the third times x to the third, so I'm going to just jump to the chase right now and say it's x to the ninth. So, by following that logic, I know that the third root of x to the ninth power, sorry, okay, I gotta make that clear. The third root of x to the ninth power is x to the third. It's just like what we did with squares. X to the third power is x to the ninth. That means the cube root of x to the ninth is x to the third. So I'm having trouble with my stylus here. Okay, let's say x squared to the third power. So x squared cubed gives me x to the sixth. Therefore, the cube root of x to the sixth is x squared. What about x to the first to the third power? We know that's x to the third. So the cube root of x to the third is x to the first. Again, if I'm taking the cube root of something now, let's look for the pattern. If I'm taking the cube root of x to the ninth, I get x to the third. Sixth, I get x squared. Third, I get x to the first. Now, when I'm taking the cube root, the exponents of the root come out to be 1/3 of that. So that a third of 9 here is 3. A third of 6 is 2. A third of 3 is 1. So if I take the cube root of x, I once again have x to the 1/3 power. So far what we've seen, both with square roots and cube roots, is that if I'm taking the nth power of a, I have a to the 1/n. In the squares, if I took the square root of, 36, I have 36 to the 1/2 power. In cubes, if I take the third root of 27, that gives me 27 to the 1/3 power. Let's talk about 27. If I say the third root of 27 squared, what that means is that we already know, we just said that that means 27 to the 1/3 because it's the cube root. But now I want to square that. And I know that my exponent rules tell me when I'm raising something to a power, I multiply the exponents. And 1/3 times 2 is 2/3. So what this proves is that any number, if I'm taking the nth root of any number to the m power, I have, well, actually, let's color code this. Let's make this n, and this m. It equals a to the m over n power. And furthermore, if I wanted to simplify this, I would take the third root of 27. What raised to a third power is 27? The answer to that is 3. And then I would square it, and I would get 9. So the third root of 27 squared is 9. The one final thing that can become confusing here is what about positives and negatives? I know if I take the square root of 64, it could be 8. Actually, you could also have the other root, the negative root is negative 8, but we're not going to talk about that right now. If I take the cube root of 64, what times itself, what to the third power is 64? And that answer is 4. If I take the cube root of negative 64, what raised to the third power gives me negative 64? I can say that that answer is negative 4. Because if you think about it, negative 4 times negative 4 times negative 4, since they're an odd number of negatives, it turns out to be negative. But what if I wanted to take the square root of negative 64? Well, the truth is, in real numbers, there's nothing times itself that will give me negative 64. So that is there are no real numbers that can be the square root of negative 64. So in general, you can take odd roots, and when I say roots, I'm talking about this number here, odd roots of negative numbers, but even roots of negative numbers are not real numbers, and you should designate that if you see it.